Welcome to another LFX Jamb preparatory class. Today we are going to be talking about number bases. From the Jamb syllabus, the Jamb objective for number base is for students to actually know how to perform these operations: multiplication in number base, addition in number base, subtraction and division. Another objective is for students to actually know how to convert one base to another. You can convert from base 2 to base 10, from base 10 to base 8, from base 9 to base 5. Then the final stuff is to know how to perform operations in modular arithmetic. So right now, when we're done with all these objectives, we should be able to solve any question Jamb throws at us concerning number bases. Counting numbers can come in different bases. We have the base 10 numbers, which is also known as the decimal numbers. A decimal number ranges from 0 down to 9. So we can count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The octal numbers, which is the base 8 numbers. Base 8 number ranges from 0 to 7, which is 1, 2, 3, 4, 5, 6, 7. We have the binary numbers, which is the base 2 numbers. Binary numbers just have 2 digits, 0 and 1. We have base 9 numbers, we have base 7 numbers, we have base 6 numbers, we have base 5 numbers. We even have base 16 numbers. They are called hexadecimal numbers. Hexadecimal numbers ranges from 0 all the way to 9. Then after 9, we have A, B, C, D, E. So this is 10, 11, 12, 13, 14. Then F, 15. So we have from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If you notice through this rundown, a base 10 number ends with a number 1 lower than 10. A base 8 number ends with a number 1 lower than 8. A base 2 number ends with a number 1 lower than 2. So a base 5 number will have digits ranging from 0, 1, 2, 3, and 4. So we don't have 5 in base 5 number. A base B number is going to have a number ranging from 0 up to B minus 1. Throughout our growth in mathematics, our brains have been programmed to easily process base 10 numbers. So what if we have a number in another base? How do we represent it, or how do we translate it to a base 10 number which our brains can process easily? Let's have a sample number: 5, 7, 8, 3. In base 10, this number can be written this way. And in base 10, this number represents 5,783. If we want to represent this number in base 10, we just put 0, 1, 2, and 3. So we just say 5 times 10 raised to the power of 3 plus 7 times 10 raised to the power of 2 plus 8 times 10 raised to the power of 1 plus 3 times 10 raised to the power of 0. So if we punch this correctly in our calculator, we'll get the value of what this number stands for. So this is just simply 3 times 1. Anything raised to the power of 0 is 1. So 3 times 1 is 3. 80. 7 times 100, because 10 raised to the power of 2 is 100. So this is 700. 5 times 1000. 10 raised to the power of 3 is 1000. So we have 5000. So this is 5,700, 8 tens, and 3 units in base 10. What if this same number is given in base 9? 5, 7, 8, 3 to base 9. If we notice no digit here will be equal to 9 or above 9. So for a base 9 number, the highest number we can get is 8. So if we are given this number in base 9, what does this number mean in our base 10 programmed mind? So we just simply have 0, 1, 2, 3. So we have 5 times 9 raised to the power of 3 plus 7 times 9 raised to the power of 2 plus 8 times 9 raised to the power of 1 plus 3 times 9 raised to the power of 0. We have 3,645 plus 567 plus 72 plus 3. So this is what this number right here in base 9 represents in base 10. So if we add this number together, we have 4,287 units in base 10. If we have this number to base B, and we want to know what this number in base B represents in base 10, we simply say 0, 1, 2, 3, 4. I just changed the number a little to have more digits. We simply say 2 times B. B could be any base at all. Raised to the power of 4 plus 5 times B raised to the power of 3 plus 7 times B raised to the power of 2 plus 8 times B raised to the power of 1 plus 3 times B raised to the power of 0. So this number in base B represents this in base 10. So technically, I've just shown you how to convert different numbers from different bases to base 10. What about fractional numbers like decimal numbers? Assuming we have a number like 8723.65 to the base B, and we want to know what this number means in base 10. Like, we want to convert this number from base B to base 10. What we'll simply do is, from here we'll count 0, 1, 2, 3. Then here we'll count -1, -2. So we have something like 3 times b raised to the power of 0 plus 2 times b raised to the power of 1 plus 7 times b raised to the power of 2 plus, let me clean up this, 8 times b raised to the power of 3. Then for the fractional part, we put plus 6 times b raised to the power of minus 1 plus 5 times b raised to the power of minus 2. So assuming this was a given base, let's just say maybe it's base 9, we can actually impute this and punch out the number that actually gives a base 10 number.